Okay, question 4. Some people are going to be delighted when they see this question, and some people have the opposite reaction because it's a proof of a trigonometric identity. And the reality is, if you know it, if you practice it, you're likely to get full marks. And if you don't know it, it's just not going to come to you inside the exam. What you're being asked to prove is that in a triangle, which has three sides, A, B, and C, the angles opposite A, B, and C are capital A, capital B, capital C, as is shown in the diagram. Prove that A squared equals B squared plus C squared minus 2BC cosine A. So obviously we recognize it as the cosine rule. So, okay, what do we do? Well, again, this is what I mean. It's not going to come to you to just draw this particular diagram unless you know it. What we're doing is we're drawing a circle of radius C. Radius C. We have a point at B0, so it's on the x-axis. It's a distance of B from the origin. We have a distance from this point here. Maybe I'll just talk about the point first. It's in polar form because the angle here, the argument is A and the radius is C. We have the point C cos A, C sin A. And then we have a distance here, a distance of A units from C cos A, C sin A to B0. Okay, that's our starting point. What do? We use the distance formula to find the distance between C cos A, C sin A, all the way down to B0. So what do? We fill it in. x2 minus x1 to be squared plus y2 minus y1 to be squared. We fill it in. We square it out. So look, I'll start with the kind of easier one. There's just a little typo here on the screen. Let me just try this. So this guy here is a little typo. Let me scribble him out. Okay. It's C sine A minus 0 to be squared. So let me just show you what this becomes. The 0 disappears, and all you're doing is you're squaring C sine A to be squared, so you get C squared sine squared A. Okay. Our bracket over here on the left-hand side is a little bit more difficult than that. Again, if you know it, you've done it a number of times, you're going to be fine with it. We square the first one, so C cos A becomes C squared cos squared A. We square the last one, minus B to be squared becomes plus B squared. And then we multiply the first times the last and double it, we get minus 2BC cosine A. So you look at what you have, you look at what you want, and you try to work towards what you want. Okay, so we can say we have our A squared, you can bring over your B squared and C squared, and then you've got this part here. Well, let's just have a look. What do we have? We have C squared cos squared A and C squared sine squared A. So we've factored out the C squared, we get C squared times cos squared A plus sine squared A. And then we still have our minus 2BC cosine A. We use as an axiom here at this point the first of the trigonometric identities, that cos squared A plus sine squared A is equal to 1. We don't have to prove it or anything like that. We just accept it as true. And we have our answer, A squared equals B squared plus C squared minus 2BC times cosine A, 15 marks.
So this one's marked on a 0, 5, 10, 15 scale. So low partial credit here is work of merit, so any correct step. So an example of a correct step could be some correct substitution into the distance formula. Okay, so any correct substitution into that distance formula would count as work of merit in this case for your 5 marks. For high partial credit for here for 10 marks, we're looking at a correct approach, but you might have 1 or 2 minor mistakes. Okay, so anything up to 2 minor mistakes here would count as high partial credit. So an example of a minor mistake is that you had the sign wrong in front of the 2BC cos A, or you incorrectly factorized out the C squared, and you might have put a bracket around the B squared and the C squared, and then a bracket around the cos squared A and the sine squared A. So it's not just taking out then the C squared as you need to. Okay, so they would be examples of errors that you might have, but 1 or 2 mistakes in this case would be 10 marks for high partial credit.
Perfect. And again, 15 marks, that's 5% of the paper. for a trigonometric identity that some of you just rattled off without thinking, and obviously some people would have struggled to get started with. So it just shows the importance of it. This next question was there to just kind of, it was a tester. It was a tester. It says, using part A, show that b squared minus a squared is equal to b cos A minus a cos B. So look, this is tricky. There's a good chance that I suppose nobody that the students have never done this particular question. So that's what we're hoping for. We of course know the cosine rule as a squared equals b squared plus c squared minus 2bc cosine A. But there's nothing at all that means it says you have to start with the a squared. So you can of course start with the b squared equals a squared plus c squared minus 2bc cosine B. I said that wrong, minus 2ac cosine B. And you'll note that the letter B and the angle B, so like I should say it again, the side B and the angle B are opposite each other in the formula, just like they are opposite each other in the triangle. Similarly here, like the side A and the angle A are opposite each other in the formula as well. So you could have C by itself. You could have C squared equals a squared plus b squared minus 2ab cosine C. Any of those possibilities, they're all fine. Okay, what happens here? Let me do this with my let me do this here with a different color pen for a second, because I know there's quite a lot going on in that line. So here's what I'm going to do. I'm going to get the red pen. Okay. So what we have here is we have b squared on my right hand side. That's the same b squared over here. But I'll put my a squared here in red because that matches up with this guy up here. Okay, so I'm subtracting the a squared, the left hand side of this guy here from the left hand side over here. So b squared minus a squared. So I must do the same for the right hand side. So if I look here, I have my a squared plus c squared minus 2ac cosine B. That's the same thing I have here, a squared plus c squared minus 2ac cosine B. But here's what I'm subtracting. I'm subtracting from that the b squared plus c squared minus 2bc, which is what I have up here. So just to summarize again, it's b squared minus a squared equals the right hand side here minus the right hand side there. Okay. What do? I simplify it down by multiplying through the brackets. You're going to notice that the c squareds cancel. I keep going here. I keep an eye on what I want. B squared minus a squared is equal to c b cos A minus a cos B. I look down at what I have. I'm not a million miles away from it, so I just keep working towards it. My left-hand side is absolutely fine. So what am I going to do? I know on my right-hand side here, if I'm looking back at what I want in my final answer, there's no a squared and b squared. So I bring them over to the left-hand side. And I end up with 2b squared and 2a squared. So I just factorize out my 2. So I have 2b squared minus a squared is equal to 2bc cos A minus 2ac cos B. I'm going to divide across by the 2. So the 2's are all going to disappear at this point. And let's just have a look. It's one thing I always like about these type of questions, that like at the start you mightn't have an idea how you're going to get to the answer. And then all of a sudden, you've divided across, I've factored out the common factor, which is C. I look at my line here, I look back at what I wanted, and bingo, I have it. 10 marks.
So this one's a 0, 4, 8, 10 scale. So for low partial credit here, for your 4 marks, we're looking for work of merit which is any correct step to get to the answer. So that would be just writing out b squared equals a squared plus c squared minus 2ac cos of b, because that is a correct step, a working step to get to your final answer here. Okay, so that would get you the 4 marks there. For your high partial credit, we are looking for correct method, but 1 or 2 mistakes. Now you can count, when I say 1 or 2 mistakes, I also mean that could be steps missing. Okay, so you might have got to the line that says b squared minus a squared equals a squared minus 2ac cos b minus b squared plus 2bc cos of a. that would count as a high partial credit because that is 2 steps away from being the correct answer. So you could count those 2 steps that are missing as 2 mistakes that you've not done. Okay, so if you got to the line, so on, would you mind highlighting that line for me? Third one from the bottom, please.
Yeah,
that
I'm
one.
I'm in the right place. So, okay.
Yeah, so if you got that line, that would count as high partial credit here. Okay, so if you got up to there, it counts as high partial credit, and that is indicated in the scheme as a high partial credit line. Okay, if you got further on than that, and there are mistakes there, and you don't end up with the correct answer, that's fine. As long as you get to that line, you can count that as high partial credit.
Very good. Simple as that, Andrea? Maybe not.
Simple as that.
Yes,
A little bit
very
tricky.
good. A little bit. Okay, so again, some people are just wanting to put that one behind them. They're moving on. It might well be the worst answer for the worst marks for some people. But you know what? Some people there, if you got 25 out of 25, give yourself a pat on the back for that one. Okay, let's move on. We're moving on to question 5.